the random variable. Let's start from an example. For example, we are throwing a fair six-sided die. So we use capital letter X to represent the outcome. So the outcome can be 1, 2, 3, 4, 5, 6. So the probability that the outcome equals 1 is 1 over 6. The probability that the outcome equals 2 is 1 over 6, and so on. The outcome the outcome equals to 6 is also 1 over 6. So here the x is an example of a random variable. The value of x depends on the chance. For example, the chance that x equals 1 is 1 over 6. The chance that x equals 2 is 1 over 6. Now, to be more clear, the random variable, it has two types. There are two types of random variables. One is discrete random variable. Another is continuous random variable. So the difference between discrete random variable and continuous random lies that the possible values of discrete random variable is limited. It's finite. For example, for this example, this example is example of a discrete random variable because its values it has only 6 possible values. It's 1, 2, 3, 4, 5, 6. So its values are limited. But for a continuous random variable, its possible values are countless, are infinite. Later we will see examples of continuous random variable. We will know more about this kind of random variable. So now let's talk mainly about the discrete random variable. So normally we use a capital letter to represent a discrete random variable. For example, in this example, we use capital letter X to represent this random variable. And we use the equivalent lowercase letter to represent its values. So we use, so for this example, we use lowercase x to represent its values. We use lowercase letter x to represent the 1, 2, 3, 4, 5, 6. And now we can use a table to show the information about discrete random variable. For this example, we can write a table as this one. Here is small x. The small x represents the possible values of the random variable. So the x can be 1, 2, 3, 4, 5, 6. And the probability that the random variable equals this value are listed on the second line. For example, the probability that x equals 1 is 1 over 6, equals 2 is 1 over 6, 3 1 over 6, and so on. And a table like this A table like this is called probability mass function. So the probability mass function it's related to the discrete random variable. So this table is called probability probability um, mass function. This table also called probability distribution. Probability distribution. The probability distribution has a property that is the sum of all the probabilities is 1. In this example, the sum of all the number 1 over 6 is 1. You know we have 6 1 over 6, the sum of them 1. So now let's look at another example. So in a game, you throw a ball to this target. This target has 4 regions. It's 1, 2, 3, 4. We assume that you can always throw your ball to this region, and the probability of hitting each region is proportional to the area of the region. If you hit region 1, you will win 1 chocolate. If you hit region 2, you will win 2 chocolates, and so on. If you hit region 3, you will win 3 chocolates. And now let the number of chocolates you win to be the discrete random variable. So this example requires us to get the probability distribution. Now let's resolve this question. We use the small x to represent the possible values of this random variable. So the possible values are 1, 2, 3, 4. You can only win 1 chocolate or 2 chocolates or 3 chocolates or 4 chocolates. So the possible values of x are 1, 2, 3, 4. Now the probability that the random variable equals each value is proportional to the area of the corresponding region. For example, the probability that the random variable equals 1 is proportional to the area of region 1. The probability that the random variable equals 2 is proportional to the area of region 2. Now we know the area 1 is 0.7 multiply 1.0. This equals 0.7. Area 2 is 1.2 multiply 1.0 equals 1.2. Area 3 is 1.2 multiply 1.2 equals 1.44. Area 4 is 0.7 multiply 1.2 equals 0.84. The probability that the random variable equals 1 is proportional to area 1. So we can write this probability as 0.7 key because area 1 is 0.7. We will get the value of k later. The probability that the random variable equals 2 is proportional to area. So we can write this probability as 1.2 k. and this probability is 1.44k. And the probability that the random variable equals 4 is 0.84k. So this is the probability distribution. Now we need to get the value of k. We know the probability distribution has the property that the sum of all the probabilities is 1. So we can get the equation 0.7k plus 1.2k plus 1.44k plus 0.84k equals 1. So use this equation, we can get the value of k. So the value of k is 0.239. Now we put the value of k back into these terms. We will get the answer. We will get the final probability distribution. Notice letter x. 1, 2, 3, 4. Probability random variable equals locus x. Here is 0.167. Here is 0.287. Here is 0.314. Here is 0.201. So this is the final answer. This is the probability distribution of the random variable of this question.